Be able to see that now. There we go. Thank you, Sindhu. All right. Welcome, everyone. My name is Adam Jones. I am with Sustainable Buildings Canada. Hopefully, everyone who has joined is already on our network, and hopefully, I've met most of you by this point. Today, we're joined by some really great guests to talk about a couple of topics that are. The title is, I think, maybe a bit confusing, and maybe will send us off thinking about what it is. But we've called it hybrid passive heating and advancing blue-green infrastructure design. If you had joined us a little bit early, you might have heard some of our conversations already. Both of these sessions are really fascinating topics. All of our speakers really have come to us today with really fascinating things to talk about. And so it might be a bit of a challenge for us to stick to our schedule, but here's what we're going to try to do. I'm going to wrap up this introduction as quickly as possible so we can get down to it. But I just wanted to welcome everyone and give you a bit of an overview of what we're doing and what we have available. We're hearing today from Dr. Corey Dawson about advancing blue-green infrastructure design with synthetic 3D drainage channels. And then follow that up with Aurelie McPherson and Wendell Star Blanket to talk about their Blanket of Warmth project, which, again, a hybrid passive heating system. It is a fascinating technology, but also the process of development and how it's going to be applied is really quite incredible. So first things first, for anyone who is new to Sustainable Buildings Canada, we have a lot of resources on our website for new construction. As many of you know, we still operate the Savings by Design program for Enbridge. And from that flows a lot of research around new construction. How can we make new buildings have a lower impact on the environment, reduce their energy consumption, and improve the outcomes for people who are living in those buildings? So that's number one. And then number two, resources for existing buildings. So I'm doing this in a very quick manner. We have a lot of programs ongoing, and if you're interested in learning more, please go to our website. We are running several programs funded by NRCan right now for new and existing buildings, in particular the Energy Spring program, which many of our members and network have been involved in over the years. We're scaling that up. And so we have some upcoming workshops with social housing providers that we're really excited to finally have some movement on that program. It is a really great opportunity to improve existing buildings for the people who are most vulnerable in Canada. And so our part of that is working with social housing providers in Ontario to try to get overcladding retrofits scaled up and moving a lot faster than they are. All right, so after the webinar, we were going to send out to everyone who's registered the slide deck, recording of the webinar, and contact info for everyone. And as always, we put these videos on our YouTube channel, so you can follow that link there and find us. We've got, I don't even know how many webinars up there now, but lots of resources. And we've been running the Green Room podcast as well, so there's a lot of those. Our aim is to get as much information about green infrastructure, green buildings, and technical solutions to help people sort of get past the lowest common denominator and to get to better buildings. All right, during the webinar today, we are operating this as a Zoom call, so please keep yourself muted until the question period. But what we will do is after the presentations, we will ask for questions. If you have some, feel free to put them in the chat and I can read them out. Or you can, I think you can raise your virtual hand and I can call on you. And barring all of that, if I call for questions, open up your mic and just say politely, I have a question, and we'll let you just sort of keep it concise as we can, because as I said, we're sort of on a short time period this one. So I'm going to briefly introduce our presenters today. So we're starting with Corey Dawson, who is an assistant professor of landscape architecture at Dalhousie. And he teaches courses in landscape analysis, grading and drainage, planting design, and the independent design studio. So Corey came to us through the LACF, Landscape Architects of Canada Foundation Federation. Uh, Someone knows the correct acronym, and I'm sorry, I always get it wrong. So Corey is going to give us a presentation today about his research focusing on nature-based solutions in climate adaptive riverscape design and habitat restoration. All right, and then following that, we'll have a joint presentation with Aurélie McPherson and Wendell. So first, Aurélie has based her working and volunteer career in 3 words: intention, attention, and action. She's worked at McPherson Engineering since the company began in 1996, and McPherson Engineering owns 7 patents for the product called Radiant Lake that we're going to learn about today. And then Wendell Star Blanket is a Nahiawak Cree from the Star Blanket First Nation located in the Treaty 4 area. He's married to Sonia and the role model to his 2 stepsons, Devereaux and Dylan. And currently Wendell is employed as the traditional knowledge keeper contracted with the Regina Public School and as a speaker of the House for the Federation of Saskatchewan Indigenous Nations. So I just want to note here that I didn't actually get to meet, but I saw the presentation that Wendell and Aurélie gave at the Saskatchewan, Build Green Saskatchewan conference earlier this year. And I was struck by this beautifully simple and attentive system that you've worked together to design. It is really just, it really struck me. Out of everything that I saw at that conference, a lot of it was very inspiring. But this, for me, captured exactly what we try to do at Sustainable Buildings Canada, which is to notice the problems that buildings are causing with people and find ways to solve those, and ideally in simple and inexpensive ways. And I think this is a great example of it. So with that, I'm going to hand things over to Corey, and he's going to start us off.
All right. Excellent.
I think there. Now, if I stop sharing, you will have.
Okay.
There.
So there we go. There. And
Perfect.
so okay. So is everyone able to kind of see that slide?
Yep, looks good. Sounds good. Take it away,
Okay.
Corey.
Awesome. Thank you. All right. So thank you for the introduction. My name is Corey Dawson. My presentation is on a project that's referring to kind of a framework for advancing blue-green infrastructure design by modeling and kind of testing and using these synthetic drainage channels. So funding was provided through Sustainable Buildings Canada that partnered with Landscape Architecture Canada Foundation, the LACF. So I'm very thankful for that collaboration. It allowed me to do this research project and fund a Bachelor of Landscape Architecture student, Ian Logan, to complete this work. So from the original intent, it kind of broadened in scope, this project. So we separated into 2 kind of sections, which will be 2 publications. One is currently published in Nature-Based Solutions, and we're finalizing another one. But the first part is kind of setting up this multidisciplinary design framework for green infrastructure. That part's addressing more of a water or river restoration approach, and then it's translating that same approach to blue-green infrastructure as far as drainage design approaches. So I wanted to structure this just with a bit of a background, looking at design simplification, so how we simplify natural landscapes that are tend to be more complex through design, some ways to measure that complexity and ways that we can model things in the planning phase to help advance kind of blue-green infrastructure design and nature-based solutions. So starting out just how we simplify landscapes. So whenever we're building or designing anything for humans, it tends to be a simplification of what nature does. So we have patios, walkways, we have grading standards for ramps, we need accessibility. Subgrade drainage systems are kind of linear highways. The way we farm, we need kind of flat, smooth surfaces and reduce the overall grade for a bunch of reasons that are required for us to use these landscapes. Um, but when we're comparing that with nature, we often see much more irregularity as far as surface geometry. So in natural landscapes, we have kind of blown down trees that causes pits and mounds. Everything, the surface is really irregular and it's always evolving. So nature is always going through these process form relationships. It's not a static landscape, and you're kind of hard pressed to find a really smooth, flat surface. Even like in a grassland, you'll have these little pits and mounds. Nothing is really as simplified as we design them through grading and kind of things that we build for humans. So when those kind of natural processes kind of work against us or in situations where we get things like erosion that are encroaching on our built infrastructure, rilling and gullies that start to form from high rain events. So we tend to try and combat against those natural process form relationships in order to stabilize these kind of slopes and designed landscapes. So that all generated in my master's thesis. I was working with Dr. Robert Corey, and he kind of proposed this question that he always wanted a student to look at how we're simplifying landscapes through grading design. And then I brought that idea into my PhD with Dr. Peter Ashmore, focusing more in on how we design rivers. So historically, rivers took a similar kind of simplification approach. The most extreme example, like in this image, is the Los Angeles River. For a number of reasons, rivers get channelized, so they get straightened, and often they're stabilized with things like concrete. And this kind of became a problem when we had more and more development, more urbanization, because this type of design, if we have a straight channel, smooth surface that's more impervious, there's less water infiltration, water is moving faster, there's less roughness on the surface. So we're getting more water traveling faster, which tends to be a problem in many situations. So there, in the last decades, we've been kind of targeting these channelized reaches with restoration approaches. So the natural channel design method is a common one in North America. Essentially, we're just trying to redesign what a river would look like, re-meandering it, putting in pools and riffles, some more habitat. And as a result, that's from a geomorphic perspective, you're increasing that complexity compared to the really simplified, kind of hard engineered approach to dealing with surface water. But somewhere along the way, we also started to target channels that were behaving naturally. So they were creating these irregular surface forms. Rivers are really dynamic systems, so they were encroaching on our infrastructure, and we needed to kind of design against that and stabilize these channels because we didn't want too much migration where it starts to erode existing infrastructure. So then natural channel design and similar approaches were kind of implemented. However, when we're using these designs for rivers that are actually responding naturally, we're getting back to like a simplification of what the river and the natural processes are actually trying to do. So this is kind of enhanced when you're thinking about more urbanized sites. We really try and stabilize rivers because we don't want them to interfere with existing infrastructure. So often it'll implement kind of larger boulders, larger sediment to kind of stabilize, reduce that erosion. And when we're in really dense urbanized areas, we really don't want these channels to do their natural thing and adjust and move and migrate through because that's going to be kind of causing problems for the surrounding infrastructure. However, rivers are really dynamic systems, so changes in upstream will affect downstream. And when we have really urbanized areas, it increases imperviousness, flow velocity, and water volume as far as surface water. So the more urbanization we have, the more water traveling faster into these channels. And some impacts downstream from these kind of urbanizations and stabilization of these channels can result in like more flooding, more erosion, and actually amplifying those negative impacts somewhere downstream through those river systems. So in the fluvial geomorphology literature, they're proposed more process-based restoration, which is essentially trying to design and allowing streams to do their natural thing, migrate through erosion, deposition, and sediment transport. So we're not getting that same more rigid approach to design. So it's less like this symmetrical, meandering kind of approach and something that's much more irregular and adaptable to changes in the river system. But there's always a balance, and it's difficult to implement these things. It's hard to engineer and project how rivers will respond. So these multidisciplinary projects, the ecologists and fluvial geomorphologists want to restore that natural complexity, but the community and public tend to like naturalness, but not too much wildness. That's perceived as a bit like dangerous if we start to erode too much. And engineering for stability, there's kind of always this balance between complexity, but we don't want too much complexity in design. So we need to kind of figure out ways how to quantify and measure complexity in the planning phase when we're implementing these kind of designs. So in my master's work, I use this compound terrain complexity index. It takes digital elevation models and essentially gives it a value with some different metrics on how complex a topography is. So with that research, we're able to get 17 real world projects and essentially compare the existing value with the proposed design or construction of these sites. So this bottom example here is an existing topographic DEM, and then they were implementing some sports fields, and we can kind of quantify and say this design would reduce complexity by 44% proportionally. So just trying to give it a value in the design decision-making phase. So I brought that general idea into my PhD, and we developed a geomorphic form variation approach, GFV. It's the same kind of thing. We're using flow direction, aspect, and plan form curvature, and we're added this variety metric to essentially quantify complexity that can be compared. We use Flume DEMs originally, and we could actually map out these hotspots so we can say this area of the channel statistically is more complex based on the metrics we applied. And then we can couple that with additional mapping things that have some ecological value. So looking at pools, riffles, and other formations in the channel. Part of that research, we were able to get 28 restoration projects. We categorized those in stabilization, full realignment, and habitat enhancement. And we found, which we were hypothesizing, is that all the stabilization-driven projects were simplifying existing rivers. So we can look at get into more details on the specific changes in metrics in those. But just an example, we have these DEMs mapping some things in the existing channel. And then we're comparing that with the proposed restoration design and seeing as far as that GFV metric, how much these kind of designs are simplifying the overall complexity of these rivers. So then to help out with that, we also thought about digital modeling. So we incorporated this river builder tool, which is developed by Rocco Brown and Greg Pasternak. I love this tool. We use it for river design, but it can also be used, which I'll show in a moment, for drainage channels, so like bioswales, for example. And you can put in, it takes in user scripts, and you can essentially say, I want a channel that's this long. It takes in some pretty basic inputs, but the value in this is that it creates these three-dimensional river surfaces that incorporates some of the principles in fluvial geomorphology. So it will generate bars where flow velocity is fundamentally lower, so you'll get more deposition, and then pools where velocity is higher, so there'll be more erosion as it's creating these synthetic 3D models. So we tested out a bunch of these, increasing in complexity, like we added roughness, made the channels more irregular from simple straight ones, adjusted the channel widths, and we were able to use the GFV to kind of quantify that for that research. So all of that kind of brought us to this project, which is we're proposing a framework for advancing blue-green infrastructure. Essentially, we're taking an existing digital elevation model or existing surface. So in this situation, this is a river channel, but the same thing would be applied for a conventional drainage channel or swale. And you could take that DEM, you can use River Builder to create a synthetic channel, and you can merge those together in something like Civil 3D to create this new synthetic kind of continuous 3D model that you can work with and do a bunch of testing with, which is really valuable in the design and planning phase. So this is just kind of a conceptual framework of how it could work if you get the topographic data. You can create some different scenarios with River Builder, work with landscape architects, hydraulic engineers, do a bunch of testing, decision-making, revisions, up until you get this kind of novel blue-green infrastructure design that's in the form of a 3D model that can be presented and rendered as well. So for the project, we looked at Bedford, which is in Nova Scotia. And Bedford Place Mall has a flooding issue. So this image here was in 2023. It has the 20-year and 100-year flood maps here. The hydrograph kind of peaked from this flash flood, which is an issue. The site does have subgrade drainage, but we took this approach and applied a framework first upstream, where there's this existing rifle range, and we proposed a river restoration design for the upstream area, and then we proposed a drainage solution using that same framework on site as far as a bioswale proposal. So for the upstream restoration, we wanted to increase water storage, decrease flow velocity to allow more infiltration, and then conceptually decrease that peak flow downstream that was causing all that flooding at the Bedford Place Mall. So we're able to take the DEM and create three different river design scenarios. One's relatively simple with symmetrical meanders. We also had some simple planting layouts for each of these. Scenario 2 was a bit more irregular. We had a wetland in there. And then scenario 3 is a multi-stream kind of approach to design. Again, trying to slow down the river, allow more infiltration, so we get less flooding downstream. Once we have these three digital elevation models, then we could do a bunch of hydraulic and morphodynamic testing. So the first thing we looked at was flow velocity. So these are the three design scenarios. We can model how flow velocity is responding to these different channel design scenarios, where they peak, And then we could also look at water depth and see where the water is pooling. So we want to hold as much water upstream on these sites as possible, which we can kind of quantify and statistically map through these simulations with kind of a variety of software. This one we use Basement, but we can use HECRAS and a bunch of hydraulic approaches to kind of look at that. We then did morphodynamic modeling. So that's just sediment transport. It's projecting where sediment's likely to be deposited or where erosions are likely to occur. So we could look at where that is projected to happen, and we could bring in something like our GFV model to say scenario two has the highest original GFV value, but how does that change after these morphodynamic models? So this is kind of a projection of how the river will respond to flooding in the future. And when we have these 3D models, we can also go back and forth and work with them. So if we have flooding that's occurring here, we know that deposition is likely to occur. We can implement, for example, a side channel here and then retest it and see how that hydraulic system is going to respond to this new overall design. And then also with 3D models, we can do things like rendering perspective, so you can get an idea of what these models would look like. This was rendered in V-Ray by Ian, just to give a sense from a human perspective what these designs would look like as far as implementation. The second part of this project is looking more at the site, Bedford Place Mall. So we did some flood mapping and targeted an area where the floodwaters were first starting to breach the mall structure. So here we did 3 drainage channel kind of simulations or models. Same approach, we use River Builder. The first one was just a simple kind of straight shot with this drainage channel. We wanted that floodwater to be diverted behind the mall structure. And the next 3 scenarios, we use River Builder and kind of increase the kind of geomorphic complexity as we went through. So scenario 3, we had variation in the width, and then scenario 4, we had some morphological features. So we had pools and riffles in that channel to more mimic somewhat of a river rather than kind of a straight bio or a straight drainage channel. So similar to our first kind of approach, you can do a bunch of analysis with this. You can see which scenario through time is going to start breaching that mall structure first. We could look at flow velocity differences between the scenarios, map out flow velocity, look at things like roughness, so how the planting will affect these different scenarios. And it offers just a way to collaborate in the planning phase to make decisions on what's the best scenario for the type of application and how we can make revisions in that planning phase. So this is just an example of where, for example, the floodwater would first reach the mall structure. Then in this modeling software, ARC or in AutoCAD Civil 3D, we can then add in additional elements or features. So we can add a berm, we can adjust the drainage channel. Maybe this area needs more hard engineering, so perhaps a concrete wall or something. But either way, you can kind of work with this flexible environment and then re-simulate how this flooding would then respond to that new kind of approach to design. So the overall framework is really flexible. Once you have these 3D models, you can tweak them, you can share them through rendering. For example, this little image down here to get a sense of what these designs would look like. But it's really just a framework that increases collaboration and stakeholder engagement, and it's really flexible in the way we can design, test, and revise these kind of approaches to blue-green infrastructure. And thank you. I don't know where I'm at with time, but thank you very much. I want to thank again Sustainable Buildings Canada and Landscape Architecture Canada Foundation for providing the funding for this project. And I really appreciate the support for this collaborative research. Thank you.
Thank you, Corey. Um, so I'll ask if anyone has any questions, but first, this was a fascinating dive into this. I'm wondering if, like the last bit was really about drainage channels. Early on, you talked about channelization, and I'm wondering if part of the inputs, I suppose, were um, thinking about wildlife, or is it thinking about it's more about fluid dynamics, and then the sort of nature, flora and fauna sort of are attached to it that way.
Yes, so I think with our original kind of framework with the river restoration portion, I think this is where we get more into the ecological processes, like at that scope. Um, so that would be more tied into some of the benefits that like a natural river approach or a process-based approach would offer on the ecological side. So there's more freedom on this upstream area to consider those kind of things. Implementing more of a process-based approach that can tie into the ecological benefits. The second phase, it's just a lot more restricted when you have so much infrastructure. You have this confined river channel. So my idea with the project was to take the framework, but this drainage channel approach would be a bit more of a hybrid where we really need to think about where more hard engineering would be available and balance that out with more of the opportunities where we can incorporate the more ecological and planting. So especially in those urbanized areas, it's more and more difficult to balance the ecological side. So I'm more proposing this as one way to think about um, laying out a drainage channel that it's not just kind of throwing it in there and trying to get the water off the site as fast as possible, but more trying to slow down the velocity of flow, allowing it for it to infiltrate, and then using plantings to increase roughness and allow it like to soak in the water, keeping it on site a bit more, just with some more irregular geometry as a starting point.
Okay, excellent. Thank you for that. Um, do we have any questions? If you have a question, if you have a virtual hand to raise, feel free. I'll just take a scan through. Otherwise, if not, if you have a question you'd like to ask, just oh, there we go. Um, Here we go from Alex. Considering these approaches may lead to additional costs for landscape infrastructure projects, what roadblocks do you find you most commonly hit?
Mhm. Uh, yes, I think that is part of weighing out or balancing kind of with any of these multidisciplinary approaches. There's always going to be a cost benefit analysis to this. So I think if we're able to connect the upstream restoration and revise the drainage on site, it's probably worth. So this image is from Bedford. If we can kind of avoid this happening in the future, which is or economically damaging, I think the input for costs for maintaining or implementing some more landscape monitoring and maintenance costs is probably well balanced with the potential impacts of these like large flash flooding events. So there's always going to be a balance with kind of where we put the money into these kind of approaches.
Absolutely. All right. Thank you, Alex, for the question. And I'll give an opportunity if anyone has another question. Oh, I see. Let me see if it's. Nope. Zoom just wanted me to see that one twice, I guess. Um, all right. Am. I see this picture is really really indicative of how many urban places in Canada or urbanized are very much built in flood zones. We loved building in floodplains in the past, so that's a big challenge.
Yes, I think the municipality just as of this year actually expanded the flood zone as far as like allowed development. So it's even expanding further than it already was originally when this kind of thing's happening.
Yeah, wow.
Yeah.
Okay, I see another question here from Ed. What would be the difference for implementing the approach in urbanized versus rural landscapes?
Yes. Um, the main difference is if you're in a rural area, and we're outside of this heavily urbanized site, there are a bunch of more opportunities to actually implement the more process-based approaches because you have that space for rivers to react and respond um, through erosion and deposition. So we're not as worried about if the channel migrates and we get erosion in one direction or another. So there's a lot more freedom to implement a more process-based approach for rural areas compared to the more confined and restricted areas that are more urbanized. So since rivers are connected systems, I think it's always a good idea to look upstream for opportunities. So if there is more rural areas that can take this kind of response through kind of fluvial and geomorphic resilience, that can actually enhance the conditions downstream to the more urbanized areas. So a lot more freedom in rural um, landscapes.
All right. Thanks, Ed, for that question. I think, given the time, we'll cut off questions here. But if you have questions, I'll encourage you to put them in the chat, and maybe Corey, if any come up, you can answer them via the chat.
Yeah, for sure.
All right, that would be great. Thank you again for the presentation, and really, I am I am in hindsight aware that we probably could have spent an hour on this comfortably, considering how much time you put into it. It was really fascinating, and I have so many questions. So I will encourage everyone to, if you have questions, put them in the chat to Corey, and again, we will share contact information afterward as well.
Thank you.
Thank you. All right, I am going to share, to start our next presentation, I'm going to share a video that they've provided about the project. So you should just see a black screen right now, and I'm going to hit play, and if if someone could tell me if there's no audio, that's what I'm concerned about. It should work, but if there's not, please someone put in the chat. I can't hear anything.
That's where we get our good feeling, when we're cold, and good feelings when we have a negative energy sometimes, and it lifts us and it brings us warmth and it brings
No
us
sound at
energy
all.
to do more things in life.
It actually started here on Treaty 4 ground, and I had the pleasure of working with Wendell Star Blanket on some volunteer work I was doing.
I told her about a dream and a vision I had for First Nations people, and that's to help them address the water issue, water treatment plants, mold, those types of things. And she says, well, we have, interesting that you should talk about that because we've developed this system.
We figured out an easy way to use your house furnace and distribute the heat better. So rather than blowing the heat out with warm air, which results in rising heat and cold basements, we basically take a certain amount of that heat, turn it into hot water, and circulate it through radiant piping applied to the basement walls.
So we thought, well, we can't do this by ourselves. Let's bring in the best and the brightest that we know.
One of Upinor's main core values is to create better human environments. Uponor is a pipe manufacturer, so we manufacture PEX tubing for radiant heating, plumbing, and residential fire sprinkler systems. And so we first got involved in this when Oralee had contacted me with Wendell and Sonia's situation with the mold in their home. So both of our joint products come together to create the solution and solve the problem. Essentially, we take the existing furnace, and McPherson Engineering has come up with a product called Radiant Link, which essentially is a coil that heats up the water going through the pipes as the furnace is running. So once the water is running through the pipes over to the pump keeps the water circulating and reheating through the coil. It only has just a very thin insulation, and so that allows the conduction of the heat from the pipe to go to the cement and create a thermal mass. So basically what that means is you're using the whole cement wall behind the heat to create the heat. The data shows that this home was very, very sick.
As you can see behind me, this board I built myself along with my Aboriginal employees. So this offers us an opportunity to provide employment to First Nations people in the sector and also bring wealth to the community. We've taken this project on because it gives us an opportunity to bring First Nations housing up to a healthy medium for our people.
I teach a course called Capstone Project. So this is the final year project for all engineering students. There are two parts in the project. One is to compare the house where the system was already installed to a new house that didn't have the system, and compare the temperature variation, humidity levels, and so on, energy consumption and electricity consumption, and so on. Second part was to help design and install the new system in the new house. And they were very proud. I think they were very emotional even to talk about it when they started presenting their results.
The 17 goals of sustainable development, number 12 is my favorite, and that's about responsible consumption and production. And that's what this project was all about. It's like, we are not going to throw all these houses in the garbage. We are going to look for the assets and make them better, and that's what we did.
It's improved our living conditions, our breathing conditions, our allergies, our asthma, they have all disappeared. So it's been a complete turnaround in our health.
It starts at home, self-worth, self-value, Lots of our structures for our families, they're subpar in that. And that has a lingering effect on our attitudes and that, because we come from a place where things aren't even up to date as they are in off reserve. And this gives us an opportunity to bring not only our home fires up to a healthy standard. And that, and then we know we deserve better, not only ourselves, but as a people.
The more homes we get it in, the more homes we're going to save, the more lives that we're going to improve.
It's all about healing our people and making sure that they have a good life, that they live a good life. And I believe this project is so important that this project will do that.
Okay. Thank you for sharing the video. I lost you, Lauralee and Wendell. There. Um, while I get this up, did you want to just share any comments about making that video about like it's such an incredible process you went through to get this project?
I can just share that we're just so grateful for Wendell for asking the good question. And that's what Dr. Roger Petrie always said. That's what's so good about the United Nations 17 goals is it gives you a platform to ask the good question. And Wendell and Sonia asked the good question. They said, could you look at this? And so we just shifted to a different lens, sort of an HVAC lens, and we included culture, which when you're designing, just as Corey mentioned, you often don't include culture or how things previously worked. And so that's what we did. Anyways, I'll let Wendell take over. Or do you want me to go next?
Well, wait. This might have been a mix-up on my part. Wendell, if you do you have slides or you just
I
want to
think
speak to?
I sent Wendell's slides
Oh,
to you.
okay, I messed that up then. Sorry.
That's okay. I try to only make 4 mistakes a day, so I get it. I
Okay,
can go. I can
if
go if you want.
if you go first, then I'll get Wendell's slides and pull them up. I'm
Okay.
sorry about that.
Okay, so I can't move the slides.
No, you tell me when to flip.
Okay, so we're so grateful to be here and we just want to show gratitude. So, my name is Orly. I am not CEO of McPherson Engineering. I'm CEO of Embodied Systems. So, just
Oh, sorry.
clear that. Anyways, moving on to the next slide, I want to show gratitude. And I mentioned this at the Build Green Saskatchewan conference. Wendell and Sonia get a great deal of credit for asking the right question. Murdo and I went out there and Murdo said, yeah, we can do some mechanical treatments here. And of course I said, Murdo, we don't have that kind of money. How are we going to do this? And his first is like, reach out to Nicole Miller, ask her at Uponor if they'll help us. Just like I said at the conference, I paced the floor for half an hour before I phoned Nicole because I knew that if she said no, I would have to look Wendell in the eye and say, I'm sorry, we can't help you. She said yes, like that. And so that just set the project and everybody else. So I'm so, so grateful for that. I want to thank the U of R. I want to thank my dear friend Angela Pratt with FSIN. She's opened so many doors for us. Star Blanket was great to work with, the capstone student. So next slide. So I just want to talk real quick about how the conversation actually came about and how we developed the blanket of warmth. I'm going to talk about the three innovations and I'm going to talk about how we achieved it. And I'm really proud of this sign that sits in front of Wendell and Sonia's home that what we really worked on is bringing innovation and culture to create healthy homes, which is kind of what the previous speaker was talking about. Next slide. So this is Wendell and Sonia's home. And as I had mentioned, we were working on a project to protect the Copel River system. And it was suggested that we host a pipe ceremony. I had no idea how to do that. And so that's how I got to meet Wendell. And when I met Wendell and Sonia, that's when the conversation about mold in their home came up. And Wendell was very concerned that the house was making his wife sick. Next slide. So in 2018, when we took it on, my world, there was really we weren't really talking about mold. So this was kind of a new shock for us. I just want to share the last journal, ASHRAE journal, May 25. The larger community is now starting to recognize what a big problem mold is. Next slide. So 60% of the homes have a mold issue. And Wendell shared with us that they call it a wicked problem. And we're like, oh my gosh, how do we solve a wicked problem? But we thought, well, we can't not help. We have to try. And so we said, okay, let's throw everything at the wall. Next slide. So what we've landed on is that the focus has really been on more insulation, upgrading windows, and installing heat pumps. And that's really because of our energy modeling that we have, which is HOT 2000. But this is a very expensive pathway, and we did not have $100,000 to help Sonia and Wendell. So we decided to do a bit of a dive into, culture and what's been done in the past. And the teepee really is incredible what it does. And what Wendell shared with us is that the teepee, you have the fire in the middle, but they surround it with the rocks. And so when the fire goes out, the rocks absorb the heat. So you don't need more natural resources to keep the building strong. Next slide. So we took this deep dive into how, culture and how the teepee really was the first man-made structure that used radiant heating. Then the next thing we did is we took a dive into the 17 goals of sustainable development. And this is 2018, so they had just come out in 2015. And when we took on the project, we knew that, like, who did we think we were that we could solve this wicked problem? So we grabbed every tool we could find in our tool belt. Next slide. So we landed on a definition that for the project for sustainability, and we chose the United Nations Enough for All Forever. And with Dr. Roger Petrie, we learned that there are 4 pillars of sustainable development: economy, environment, culture, and social values. And we often talk about how much stuff costs up front. We're not really looking at downstream costs, and we should look at that more. But we never look at culture. And so some people say, well, what is culture? And culture can be anything from, the type of foods that you serve. So it's the culture of food. It can be the culture of hair. When you see Wendell, you're going to see he's got beautiful long hair. But that all those have an impact as to how the house works. Next slide. So we noticed that this really aligned with what we were learning at ASHRAE. And ASHRAE, if you think of ASHRAE, we know what IT nerds are. Think of these people as HVAC nerds. They love heating, ventilating, air conditioning. This is their gig. And their mission statement is to serve humanity by advancing the arts and science of heating, ventilating, air conditioning, refrigeration, and their allied fields. And their vision is a healthy, sustainable built environment. Next slide. So for this, we really focused on, so this is innovation number 2. We really focused on affordability. And this is where Nicole really stepped up. And we knew that we couldn't afford to, the cost to, pour a subfloor or, moving that, taking out that concrete and putting in a new subfloor and that concrete going to the garbage. And so this is what this innovation that Nicole brought to the table. And we're like, let's give it a go. Next slide. This is the third innovation. So what Radiant Link does is we look at the existing equipment in the space and we say, we're not going to throw this out. We are going to make it better. And so we put a coil onto the furnace that connects to the wall. So we can do in-wall heating and in-wall cooling. I am so proud. We are a Canadian company. The patents are designed by Canadian engineers. And yeah, super proud of that part of it. Next slide. So here's what we did. And this is with our infrared camera. So once we put the wall up and hooked up the system, the winter basement perimeter corner temperatures increased from an average of 13 degrees to 19. So what that meant is for mold to grow, it needs condensation. And how you get condensation is the warm air from the furnace is blowing on cold surfaces. So we activated the cold surfaces just like they did in the teepee, and we make them warm. So condensation is not possible. In the video, it says the solution was 7,000 It's actually around 8,000 now, start to finish. Next slide. So here's what we achieved. We're able to reduce Wendell and Sonia's annual savings of energy bills by $700 to $900 a year by activating the thermal mass and getting rid of the electric space heaters. We achieve 12.9 hours of passive heating. So if the power goes out, because we've activated the wall, we're working with the wall, not against it, it holds that heat for us during those power outages. And we remove the space heaters because everybody wants to be comfortable, especially when it's 13 degrees in the basement. Those space heaters are actually a result of a lot of fires. So we redesigned the HVAC system to do a better job. Next slide. And we created livable space. And so there's 900 square feet in that basement that now Sonia and Wendell can enjoy. Next slide. Blanket of Warmth demonstrated that through the lens of compassionate professionalism and social sustainability, coined by Dr. Hussein of the UR, we are able to address mold in the existing residential that is affordable and resilient. Thank you.
Excellent. Thank you, Orly. So I'm gonna switch here. I'm gonna stop sharing. I'm gonna switch over. If we have a question for Orly just as we do the switch over, feel free. And again, I'm sorry about the mix-up.
That's okay, Adam. I understand.
There it is.
Oh, yeah. So are there any plans to scale the adoption? Big news. We just got a grant, and we're able to do, we're going to be doing 11 homes on 4 First Nations. We're going to be doing a Star Blanket, Pasqua, Standing Buffalo, and Muscophedan. So we are starting to build relations and install the system.
Excellent news. Okay, there. I got the slides show. So I think that we did this in the complete reverse order of what we had originally posed. It was originally going to go Wendell, Orly, then Corey. We have totally flipped it around backwards now. Sorry about that, Wendell. But I've got your slides up. So please just let me know when you want to advance the slide and I'll move things forward for you. And you are on mute. So if you are talking to us right now, we cannot hear you.
Hello?
There we go. Now we can hear you again.
Okay. You can just show the slides and I'll speak as the slides are on, but before we start, I want to start a little bit in my language of Cree. I'll start by saying Tanse, Nutute Tamtik, Nigawagamak, Wakurtuin, Nesiga Sun Kanawakweta Kurta Skikiakamita Ta Kurt. Tante Oche Achaku Saku Taco Pit, Wapi Mostusis Treaty 4 Territory, Che. Hi, Nenas Kamun. I want to start by saying hello to everybody. Hello to all my relations. And hello to the I guess the earth, the sun, the water, and the land. And I wanted to say that my colonial name is Wendell Star Blanket. My Cree name, Nisiga Sunchi, is Kanawakwetakut. That means when he speaks. The name translates to when he speaks with power or he speaks with authority because they're the words of his people and his people stand behind him. The other part of my name, Askikiakamita Kot, means all the spirits of the earth, they hear his prayers, they hear his words, and they are right, they are just, meaning that the spirits that of the earth that will discipline me if I tell lies. So And then I went on to say that I'm from Chaco Saco Taco Pit. I'm from Star Blanket. I live on Wapimostosis White Calf Reserve, which is in the Treaty 4 territory. I wanted to also begin by correcting the Speaker of the Federation of Sovereign Indigenous Nations, Speaker of the House. So the acronym you got a little bit wrong. It's the Federation of Saskatchewan Indigenous, Federation of Sovereign Indigenous Nations. So just a little correction there. So you can start with the slide. Again, I want to acknowledge that I'm honored to be able to do this part of it. And as Orly indicated, the teepee. What people don't realize is when the wind enters the teepee through the flaps at the top, it circulates down and it circulates to the bottom of the teepee. And then what it does is it pushes the air up and the smoke out of the teepee. So that's why we have that fire in the bottom, which is why we have a fire in the middle of the teepee, is that it causes the heat to rise, which pushes the smoke out of your teepee. So that's how we have ventilation in the teepee, and your flaps control the airflow in the teepee. And so just to kind of add to that correction, and yeah, the stones at the bottom also, how do you say, they absorb the heat, but another trick for the teepee is if you put, say, example, cedar or even willow in the bottom of your teepee, that kind of absorbs heat, like the coals, like the pipes that are put in the basement for the radiant link system. They would act as a conductor of that heat, and they would warm the floor of your teepee. So a lot of people don't know that trick. I'll share a little bit with you, and I won't charge you my usual fees for that. We wanted to. This is a picture of myself and my wife Sonia, as we're holding one of the awards that we received for this project. We're in front of the house, in front of the teepee frame, and as you can see, I'm dressed kind of nice. My wife dresses me all the time. So I want to thank her for her contributions to the project. Without my wife, without the women folk behind us in this project, like Oralee and Nicole and Angela, you always need the women behind you to make sure that things are going good. And we've had the strength of our women folk to thank for that. Next slide, please. This is my brother Fred. He's the one we used as in terms of a comparative analysis. My house was done, and then there was his house that didn't have it for the first year that we started the project. He since has it in his house, and he enjoys it very much. In that his house is always warm, and he, like I said, he was thoroughly impressed, and he's a hard guy to impress. So he's been a strong advocate for the project itself, especially in terms of it addressing the mold issue in his house. Next slide, please. We have our current chief and council here. We have Chief Michael Starr, councilors Mike Starr, uh, Councillor Kathy Lowe-Stonechild, Councillor Lawrence Starr. So these people continue. Mike has been re-elected chief, but the new council, there's two old councillors and two newly elected councillors, but they continue to support this program, this project, and they're becoming strong advocates of the project. They kind of basically handed it off to me and told me just do it, and we've been doing it ever since. Next, uh, I think one of the key components or protocols, traditional protocols in terms of implementing any initiative such as this project is the importance that we started with a pipe ceremony, and the importance that we continue to go and make offerings in other ceremonies, like sweat lodges, night lodges, rain dances. We have that cultural component involved with this project because those are the traditional protocols of the Nihio and Nihil or Dakota, Lakota, Nakota peoples, and also the Sulu peoples. We all have our different cultural components or protocols or traditions, and we've incorporated a lot of them in terms of the implementation of this project. So as we move forward, we continue to make those offerings, and we continue to make that recognition, to always acknowledge our people and our ways and our culture through ceremony. And a lot of projects, I feel, lack that that traditional cultural initiative, and it's a lot of times it's hard to get that support. It's hard to get that funding to for the involvement and for the promotion of the important aspect of that cultural component that's needed in our projects of First Nations people and non-First Nations. Uh, when we sign treaties, people don't understand that when we sign treaties that there was a cultural component involved to that treaty process, and is still very much of that process today, such as the pipe ceremony and such as many of our other ceremonies. People don't understand too that it's also ceremony to put up a teepee, to have a home fire, to have a house. There's ceremonies that go with that. So next slide, please. Uh, as you can see, the system that we've designed here, this is the system that we have in Fred's house. My system is more ancient. His system has been developed or upgraded, and it's actually cost less dollars to develop and build his system and put it in his house. So as we continue to move forward with this project, we continue to be innovative and we continue to be reinventive in terms of the project itself, in terms of the system that has been developed. We continue to upgrade it, and we continue to how do you say renovate the system itself. Next slide, please. So, Radiant Link, we wanted to understand in terms of maintenance, from our perspective, from the system that's been installed in my house, in Sonia's home. We've had maybe uh, two maintenance calls since it's been in here for the past 8 years. I believe Murdo's come in and from McPherson Engineering, he's come in and he's had to, how do you say, restart the system a couple times because we had low pressure. And we had low pressure in the system, and in order to continue to recycle or continue to move through for the system to be active, he's had to come and just like how do you say reflush or restart the system, but he's only had to come in and do that a few times, and we've had no major breaks or no major breakdowns in the system itself, which is why we say that it's been very low key in terms of maintenance. My brother Fred's system, I think he's only had Myrtle over a couple times to restart the system again because of the low pressure in the system. You have to come and reflush the system so that it'll restart and regenerate again and continue to work in a proper system. I'd like to state that the system itself, there was a power outage, and I was away in Manitoba at the time, and my wife had a power outage here. It was the winter time. It was about minus 30 degrees outside, and the system kept itself. It because it had heated up or warmed the concrete, the basement. The temperature in the house here stayed the same for the next 12, 13 hours, and the power was off for 18 hours. And then my brother-in-law came and started the generator so he could hook up uh, a floor heater to heat the home. But she didn't really need it because the foundation had retained the heat, and the home stayed warm during that time. And so it was very, very remarkable system. Next slide, please. Uh, I wanted to also end by stating that when we started the system, my wife had allergy problems, and because of the mold in the house, what was happening is it was causing her to have allergic reactions, meaning she was getting headaches, she was getting a rash on her skin, etc. And once we put the system in, it kind of cleansed the air because it was shooting out cleaner air. It was heating a heated air that was being shot out to the home, and it was clean, so that it was because we were able to do away with the mold. The mold literally would dry on the wall and drop to the floor, and we just come along and sweep it up. And so once the mold got out of the house, I didn't have to take her out daily for out of the house. She was able to stay in the house for more than 24 hours, 48 hours, etc. We can now stay in the house, and we don't have a mold issue or problems with mold in our homes, in my home anyway. And that's what the system does, is it addresses the mold, which is 60 to 80% problem in our current homes on First Nations, and in particularly Star Blanket here. We get new homes, and we have to follow CMHC policies to acquire that funding to build these homes on reserves. And what's happening is CMHC and these ISC, Indigenous Services Canada, is pushing policies where they're encouraging us to build wooden basement foundations for our homes. And what's happening is within 3 to 5 years, those homes that they're pushing for us to build in our First Nations are developing mold. And if that continues to happen, within 3 to 5 years, these homes will develop mold, and you're building these homes for nothing because it isn't benefiting our First Nations. What it's doing is it's just giving us a place to occupy for 3 to 5 years, and there's no long-term sustainable development for these homes. And I'm very surprised that 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 we're allowing this to happen. And if we continue to promote the building of wooden foundations, then it defeats the purpose of Radiant Link and this Blanket of Warmth project. So I wanted to make that how do you say I wanted people to acknowledge that, and to acknowledge that we need to change the system. It's not just the heating systems in our homes, but we need to change policy. We need to change the current systems that they're trying to push or implement uh, 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 at that political level. So I want to thank you. I thank Orly. I thank Murdo. I thank McPherson Engineering. I want to thank Upanar, Nicole Miller. I want to thank Angela Pratt from the Federation of Sovereign Indigenous Nations, and I want to thank all those people who are taking their time to listen to us, and thank all those people who've given us accolades or awards. We've received awards from United Nations, we've received national awards, we've received grants, etc. And I want to thank all the people for all of their insights and for all of their beliefs and for all of their support in this project. And particularly, again, I want to thank our Star Blanket Chief and Council, and I want to thank the new chiefs and councils who are also going to be supporting this project. Chief Roger Redmond from Standing Buffalo, uh, Dakota Nation. I want to thank Chief Fabian Iron Eagle from the Pasqua Soto First Nation. I want to thank Marita Levitt from Muscopeding, uh, because these are the new bands that are coming on board with this project, and that couldn't be possible without Orly's help, without Nicole's help, without the help of so many people, and in particularly my other brother, I call him my brother now, Murdo McPherson, and we take Orly as a sister now because they're helping us. They're helping us live. They're helping us to survive and and live in a good way. So
Excellent.
I thank everybody for that.
Thank you,
Right, right.
Wendell. Thank you for that. The presentation. It is again, as I said, I'm struck by it is how simple the technology is, but how impactful it is, and how for me that it was really enlightening to see how the solution came from the people who had the problem, and it certainly reminds us all that often, as Orly said, the geeks about HVAC and airflow and sustainability geeks and all that, it's easy for us to get swept up in the technological solution and then totally ignore the problem and who's having the problem, and they usually have the answers if we talk. So thank you again for sharing this project with us.
It's been our pleasure. And I wanted to thank Dr. Is it Marnie from the University of Regina Engineering Department. He provided us with the qualitative and quantitative analysis or the science behind the project to prove that it it is beneficial, and it contributed to 27 to 30% decrease in our heating and our energy and our power bill. So the system itself will pay for itself in 8 to 10 years, maybe even less, depending on the savings that you're going to make from having this radiant link in your home. So I thank him for being able to come in and do that qualitative and quantitative analysis, or put these computer chips in the home so we could measure the air, etc. So thank you.
It is always amazing how difficult it is to explain what's happening, and then luckily there are people who have those tools that can help us. All right, I'm gonna pose the question then to the group. If anyone has any further questions, if you'd like to put it in the chat, open up your mic. I know we are a little bit over time. I want to thank everyone for staying on. But if there are any other questions, please. All right. Well, I will wrap us up then. If you have a question and you're still typing it in the chat, please continue. If I see it pop up, I'll ask before we close. But I want to thank everyone, first of all. So, Corey, Orly, and Wendell, thank you for taking the time to share your projects with us. As I said from the beginning, we probably could have spent an hour on each of these easily, but I appreciate you sort of condensing it and sharing it. Hopefully, we will share your contact information with everyone else, and they can reach out if they have specific questions. But starting there, thank you so much. For everyone else who joined us today, oh, there, I see a question has popped up. So a question further to the scaling adoption question. We have ideal and tested scenarios with forced air furnaces and a cement foundation basement, but we have the expertise to modify that to other heat sources, wood basements, etc., and we encourage any construction challenge to help solve the vast mold issue in homes in Canada. That's from Nicole Miller. So this for me is, I think this is what struck me so much about this project when I saw your presentation in Regina, was that so much of what we talk about, as I said, we get caught up in the sort of technical, energy efficiency becomes sort of a focus in and of itself. And in this case, as Wendell just said, it's surprising to me, but you're saving energy by getting a better output of the heat. It's solving multiple problems simultaneously. And yeah, the health issue related to the housing is far more important than the energy savings component, but it's nice that there's an overlap.
And I think, Adam, that when we landed on using the 17 goals of sustainable development, we just were stumbling. But it gave us a good platform to say, okay, are we reducing energy poverty? Have we addressed equity? Have we addressed sustainability? Like, it was all there. And so it just opened this door to, and so we went in with the idea, like, let's try and get rid of the mold. But because we were asking all these other questions, it's like, yeah, we can address that. We can address that. And so I really encourage, if you're faced with a wicked problem, use that as your decision-making platform. It really helps.
Yeah, that's great advice. I'm also struck by the similarity with these two. They're wildly different projects that we just saw today. But Corey, it's sort of the same thing. It is, as Orly and Wendell have said, a wicked problem. And by renaturalizing, it is really the benefits of doing that extend further beyond just solving a flash flood. Yeah. Okay. It's 12:22.
Yeah, did you know that they were so connected when you put us
No.
together? Or was it just the Big Bang Theory that we just
Yes.
lucked out?
Absolutely.
Wow.
I mean, this is the thing that keeps me doing this work is, it turns out that they're all connected. But
Yes.
yeah.
Yes. And it's interesting. That's how I met Wendell, was because they wanted to flood us. And we're like, whoa, whoa, whoa. Let's talk about this.
Love rivers, connected systems.
Mm-hmm. Mm-hmm.
Absolutely. Well, 12:23 on my clock. I think we should close things out. Thank you, everyone, for your time. Thank you again to our presenters. Thank you to Sindhu for organizing us all. And thank you to all of our attendees for joining us today, for sticking on a little bit longer than scheduled. As always, we will send out an email with the link to the presentations and the YouTube channel video when we get it up there. And if you have any ideas of things that we should do webinars on in the future, please reach out. We are always happy to share any stories and research that's ongoing. So thank you all again.
Thank you
Hope to
so
see you
much,
again soon.
Adam. Thank you.
Yeah.
We really appreciate this.
Mhm.
Our pleasure. Bye, everyone.
Thanks. See ya.